Oh my gosh, I just got an email from Bill that I actually have a homework for 291 due tonight, so I'm going to read this question here. Please find the root of this polynomial between 15 and 20 by graphical method, MATLAB roots, F0 bisection method, and Newton-Raphson. Well, I think it's gonna be an easy problem. It's just gonna be a piece of cake. So I'm going to open my MATLAB here. I'm going to create a new M file. So the first one is asking me to do the problem using the graphical method. What is the best way for me to do this? I think I'm going to use fplot since our question is already a function, so it's gonna be really easy. And I'm going to make my screen smaller so that I can look at the problem. And with fplot, I just need to type in the function, the polynomial, in a single quotation mark. So 74 times x to the 4th minus 0.284 times x to the 3rd plus 3.355 times x to the 2nd minus 12.183 times x plus 5, and again single quotation mark. I'm going to make sure that I'm typing the right equation. Yep, that looks good. And with fplot, I have to specify a range where the graph is going to be graphed. So the question is asking in between 15 to 20, so I'm going to use that. Alright, so I have this and I want to know where this function crosses 0 in the y, so I can zoom in with this and I can go further, I guess, and using this data cursor thing I can roughly pick a point where y is 0. Okay, so I get roughly at x equals 18.88 where my y is 0. Okay, and the second problem is asking me to do this using the roots built-in function. I'm going to create a new variable called xRoots, and I'm going to use the MATLAB built-in function roots. And with roots, I have to store in the coefficients of my polynomial in a row vector. So I am going to create a row vector for my coefficients. And minus 12.183 and 5. Okay, and I'm going to run it again. Oh yeah, with the roots built-in function, it will give me all the roots that the polynomial has. So in this case, we have 4 roots, although they are not in the range of 15 to 20. So based on our problem, the answer would be 18.89. Okay, and the third one is asking me to do this with the f0 function. So I'm going to create a new variable called f0 using the MATLAB built-in function f0, which is nice too because the input is gonna be our polynomial in quotation marks, so I can just copy paste it from my f block. And with the f0 we can give a single initial value, or we can give it a range. And in this case I'm going to give this a range between 15 and 20, because we know that the polynomial has roots at 13.25. So if we give a single value such as 15, it may round down to that roots. So I'm going to run it again, and with the f0 function I get a value of 18.89 for my root, which is similar to my x roots and also to my graphical method one. And the fourth one is asking me to do this using the bisection method. Again, I'm going to store it in a new variable, and I have downloaded the bisection script from the class website, and the name is bisect. The input is a, b, and epsilon, which is the tolerance. And a and b, we have to pick a value of a and b that will give the y result in the opposite sign. In this case, I'm going to pick a to be 15, because looking at this graph, at x equal 15, y value is negative number, and at x equal 20, the y value is positive number. So the y values from those two numbers are in the opposite sign. And if we look at this script again, this function, I need to create a separate user-defined function with the polynomial stored in it. So I'm just gonna go ahead and create a new function with output is y, called func, with input x, and y equals, I can just copy paste it but without the quotation mark, and save it as func. Okay, and with this I can then just call our bisection function script. The a is 15, b is 20, and I'm going to define the tolerance to be just 0.0001, and I'm going to run it again, and I get my x bisection value to be 18.8947. And if I probably try to again reduce the epsilon, the tolerance, to be smaller, and if I run it again, then I'll get my x value to be 18.8948. And the last one is problem E, asking me to do this with the Newton-Raphson method. I'm going to double click and open my Newton-Raphson function. The input that I need is xr, just an initial x value, and again the epsilon, which is the tolerance of the iteration. And if I look down further in the body of the function, I have already defined a separate user-defined function with the polynomial stored in it, but I also need a separate user-defined function where the first derivative of the polynomial is written. So I'm going to go ahead and create a new function with the output is dy called defunc with input x, and dy is equals, I'm going to go ahead and paste that thing again, but I'm going to modify this to be 4 times that, and then this becomes to the third 3 times second 2 times, and this will just be x, this is just gonna be constant, and then 5 becomes 0, and then I'm going to save it as defunc. Alright, so I think we're good to go with the Newton-Raphson. I'm going to call it x and r equals to, I'm going to call the name of the function, which is newt_raf, and my initial gas is 20, and again my epsilon value is 0.001. So I'm going to go ahead and run it again, and I also get the same value for my Newton-Raphson root, which is 18.8948. Alright, so I'm just going to go ahead and save this in a Word document and send Bill my homework solution